Okay, this last section is about probability. We're not going to go super in depth into probability. If you want to know more about it, you could take probability and statistics. Either if you're a senior, you take it in college, or juniors, you could take it next year. Mrs. Baker's been teaching it for the last few years. I don't know who's going to teach it next year. But they dive more into probability. What we're going to talk about is basic probability, which is the number of likely outcomes divided by the number of possible outcomes. And possible outcomes is called the sample space. So like sample space on a coin would be heads, tails. Sample space on a dice will be 1, 2, 3, 4, 5, 6. Okay? Probability of the union of two events. That this will occur and that will occur. What you do is you do probability of the first plus the probability of the second, and then you would minus anything that would overlap. Okay? So if you want the probability of like an even number and a number divisible by 4 and you're rolling a die. Okay? If you count 4 with the even numbers, and you'll count it with the divisible by 4, but then you'd have to subtract those at the end because those are something that's in common. Okay, we'll do examples of that. And the probability of independent events of this and that, which is different than a union. Okay, this is when you multiply the probabilities together. So probability that you'd multiply or roll a coin and get heads, and roll a die and get 3. Okay, those will get multiplied together, the probabilities, because those are separate things. Okay. All right, same thing like the last video. I'll probably talk through it pretty quickly. Because there's a lot of writing. If you want to pause to write the questions down, that's fine. It takes longer to write the questions down than it does actually answer the question. So, okay. Alright, so first thing's talking about sample space. That's like how many different things there actually are. And you're actually going to write out what the sample space is. That's why I have a lot of lines in here. Okay, when they do sample space, they do solution sets around it. So if I want to find the sample space of a coin and a 6-sided die. Okay, well if I flip a coin, let's just start heads first. I could get heads and a 1. And if you want to write out the words, that's fine. I think it's easier to just use letters and numbers. Okay. Then I would get heads and a 2. I could get heads and a 3. Heads and a 4. Heads and a 5. And heads and a 6. Okay, or I could get, because my other possibility on a coin is to get tails, so I could get tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, and tails and a 6. Okay, sample space, that's just writing them all out. It's not actually finding the probability of anything, we're just writing out what are all the possibilities that could happen. Okay, number 2. 2 county supervisors are selected from 5 supervisors, A, B, C, D, and E, to study a recycling plan. Okay, so I could get, I'm just going to go in order. So we could get A and B together, or you could get A with C, or you could get A with D, or you could get A with E. Okay. Okay, then if I go with B, well B's already been with A, so I could get B with C, B with D, and B with E. Okay, then if I go to C, well C's already been with A, C's been with B, so C could be with D, or C could be with E. Okay, then if I do D, well D's been with A, D's been with B, D's been with C, so D could be with E. And at this point now, E's been with everybody. Because E's been with A, B, C, and D. So that would be your sample space. So the first couple of questions we'll be asking about your sample space. It's not the probability. This is just finding what would go, if we were finding the probability, this would be what would be in the denominator. So we would count these. That would be 12. 12 would be in my denominator if I was actually going to use this to find the probability of something. Okay. Alright. We're going to do 2 scenarios. The first one, it gives you the sample space, and the second one we'll have to find the sample space. Okay, so this one, find the probability of the experiment of tossing a coin 3 times. Okay, and it gives you what the sample space would be. You could get heads, heads, and then heads, 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 and tails, heads, tails, and heads, heads, tails, 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 heads, heads, etc. Okay, so if I want to know my probability of anything, I need to figure out how many things were in my sample space. So 1, 2, 3, 4, 5, 6, 7, 8. So there was sample space was 8. That means that's what my denominator is going to be when I find the probability. So this says to find the probability of getting exactly 1 tail. Well, if I go up here and look, well, where did I get exactly 1 tail? So we got exactly 1 tail here, 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 and that looks like it. So how many times did that happen? Well, it happened 3 times. So my probability would be 3 out of 8. If that fraction would reduce, then you reduce it. If not, then that's your answer. Okay, I'll go to a different color for the next one. The probability of getting at least 1 head. So that means you could get 1 head, 2 heads, or 3 heads because you're flipping a coin 3 times. So go up and count. How many times do you get at least 1 head? Well, this one has at least 1. This one does. Okay, keep going until you find ones that don't. Okay, the last one doesn't. So how many of them have at least 1 head? Well, there's 7. So this would be the probability be 7 over 8. All probabilities, whatever these fractions are, have to be less than 1. Okay? I mean, you're never going to have a probability bigger than 1. 1 would be the biggest because that would be a 100% chance that you would get something. Okay? All right, one more scenario. Okay, so find the probability for the experiment of tossing a 6-sided die twice. Okay, well, if I want to find my sample space, if I toss it once, I have 6 options. If I toss it another time, I have 6 options. So that means my sample space is there's 36 total things that could happen when I roll a die. 2 die together. Okay. Now, you can think through this in your head. Sometimes it's easier for me to write out the scenarios, okay, so that I know how many times did it happen. So the first one says the sum of 4. Okay, remember you're rolling 2 die, so your numbers are between 1 and 6. So I could roll 1 and a 3. I could roll a 3 and a 1, because that's different, because what you roll in the first one is different than what on the second one. Or I could roll a 2 and then a 2. There's no other combinations that would add up to give me 4. So that means there's 3 times this happened. 1, 2, 3. There's 36 in my sample space. So my fraction would be 3 out of 36. And then I would reduce that to 1/12. Okay, number 6, the sum is odd and no more than 7. So if sum is odd and no more than 7, I could get 1, 3, 5, and 7. Okay, well, it's impossible if you roll a die twice to get a sum of 1. The smallest sum you could get is 2. So this one has no possibilities. If I want to get 3, I could get a 1 and a 2 or a 2 and a 1. So this one has 2 possibilities. If I want a 5, that could be 1 and 4, 4 and 1, 2 and 3, 3 and 2, and that would be it. So this one has 4 possibilities. And then 7, I could get a 1 and 6, 6 and 1. You get 2 and 5, which is 5 and 2, 3 and 4, and 4 and 3, which would be 6 things. So that means there's a total of 12 out of 36, which would be 1/3. Okay, last one. The sum is 2, 3, or 12. So we're going to find all the possibilities for each one of them and then add them together. So to get 2, well, the only possibility I have is 1 and 1. So there's only one opportunity here. To get 3, I could roll 1 and a 2 or a 2 and a 1. There's 2 there. And to get 12, my only possibility is 6 and 6, so that's one option. So this would be 4 out of 36, which would be 1/9. Okay, this will get you through the probability section. Remember, probability, everything should be a fraction unless it's sample space. And all the fractions should be less than 1.